Now we will practice sketching the graphs of quadratic functions in standard form, factored form, or vertex form. The definition of a quadratic function is given in the first box here. F of x equals ax squared plus bx plus c. Now this textbook calls this the definition of a quadratic function, but most commonly it's known as standard form for a quadratic function, and I will refer to it as quadratic function in standard form, but just know that the textbook will call this the definition. We have seen from our transformation practice and from our regression practice that the shape of a quadratic function is this parabola. If we have our a value greater than 0, that means it's going to open upward because it was not reflected across the x-axis. But if we have a negative a value, that means we're going to reflect down, so it will open downward. You also focus on this very important point called the vertex, which is the lowest point or minimum when it opens upward, and the vertex is the highest point or the maximum when our graph opens downward. So we have another way of representing a quadratic function, and that is called, in the textbook, standard form, but more commonly it is known as vertex form. So I know that's confusing that the textbook calls it standard form, but I am going to call it vertex form. And then there's something else we're going to call standard form, but you'll get used to it as time goes on. So the standard form for a quadratic function is f of x equals the quantity x minus h squared plus k. This form is especially convenient for graphing a parabola because it identifies the vertex of the parabola as hk. So if I am looking here in this box at this vertex form of my parabola, I see it looks just like the transformations we practiced last standard. I can see from this h here, we shifted right h units, and then this plus k means we move up k units. Well, if we shifted right k or right h and up k, then our vertex, which is initially at the origin 0, 0, would be at hk. So it's also going to have one final important part of the parabola, which is called its axis of symmetry, and that is the line through the center of our parabola that splits it into two separate halves. So the vertex always falls on the axis, and since that axis of symmetry and vertex have the same x value, x equals h will always be the equation for our axis of symmetry. So this page was a lot of new vocabulary. Let's get into some problems together now.